Okay, we're back with the second half of this video. Now, I mentioned some various parts and valves that you can buy when it comes down to steam radiators. And in the second half of the video, I decided to turn on my heating system again just so I can show you, once again, if I didn't make it clear in the first video, a good operation on a radiator. So basically, a good radiator, a lot of people under the impression that steam radiators are supposed to bang, they're supposed to make a whole bunch of noise, they're supposed to condensate and build up vapor all over your windows, which is incorrect. That just means you have a leaking system, a completely inefficient system. And as you can hear, the radiator is actually starting to heat up now. And now you might hear the hissing at first, when the heat first initially starts up, just so the radiator can vent out and heat up. But as the radiator heats up and starts to distribute heat throughout the room or the apartment that it's in, eventually the air vent should die down and you shouldn't hear it anymore, or very mild hissing if you do hear anything at all. In this case, once this is finished venting out this radiator, you're not even going to hear this air vent making any noise. But before we get into that one, as this is taking time to heat up, I want you to take a look or have an understanding of different types of radiators. Now, I mentioned before in the first video that this is strictly a steam radiator. Now, they have other radiators that work on hot water systems that look very similar to this. Take a look thus far down here. These are American-made radiators, as well as the one that I showed you in my living room that's actually heating up my living room right now as we speak. But if you take a look, there is a very big difference between that radiator and this one. The living room radiator doesn't have columns on the top as well as the bottom. You can see on this one here, which is a radiator that I worked on and refurbished myself, it has water columns to transport water from the top as well as the bottom. Now, I bought this radiator not too long ago, and I'm still contemplating what I'm going to actually put it in one of my rooms. But this was set up for a hot water system, and I converted it to a one-pipe steam system, which is, if you know what you're doing, it's not that difficult to do. But let me show you a couple of other things. A common radiator that you'll find in a lot of buildings that you won't be able to see very often are these right here. Steel element convectors. Now, these work pretty effectively and they're pretty efficient. They're very efficient, as a matter of fact. They're almost as good as cast iron. The only difference is that they won't hold the heat nearly as long, and they'll cool down immediately once the heat starts to shut, or once the heat shuts down. Now, this radiator here, the connections are at the bottom. Now, what you're seeing here is the old air vent connection, which I disconnected once I removed this radiator. As a matter of fact, I'll show you the air vent that I use currently to heat this one up when it was in connection, which was a Gordon's air vent, of course, which I pretty much recommend. Well, not this size. As a matter of fact, I do believe I have a different size. So I'm going to take a look and see if I can find that. I think I have it laying around here somewhere. If not, then the hell with it. I'll just do... Alright, I must have left that shit somewhere else. Nevertheless, you pretty much understand what I'm saying. But this is a steel convector. Basically, how this works. And this was hooked up to a one-pipe steam system. Basically, okay, let me move this back somewhat. In this case, what you get is you have an opening where you have a valve or cutoff valve connected here, which basically feeds steam or hot water into this radiator. And then you have these water or steam transporting tubes that pass water or steam in between the fins itself, and basically transferring the heat from the tubes onto the fins and then distributing the heat in that area there. Now, if you're running this on a hot water system or on a two-pipe steam system, basically what you would have here on the two-pipe steam system is a half-inch nipple that comes down maybe about 2 inches, and then you would have an elbow half-inch, and then you would have a steam trap that basically collects any condensated water and removes any condensated steam that's still inside of the radiator. But in this case, I don't have it set up like that. I have it set up for a one-pipe system where I have an air valve at the end. And as you can hear, this thing is still getting hot. Okay, we're almost there. Now, once this thing heats up, you're no longer going to hear it. And this is basically how you should hear any steam radiator operate that has a cutoff valve, or sorry about that, that has an air valve that vents automatically. So I also have two different radiators here. Now this one also is directly for steam. If you take a look between the difference of this one and this one, this has water columns that transport water or steam from the top as well as the bottom, and this one here only has it from the bottom. This is a radiator that you would commonly see that are more the somewhat modern radiators that they put in homes nowadays. They're very thin radiators with the thin sections, and they work very effectively. They're just not built with the same standards as the American-made radiators, and both of these radiators here are American-made, as well as the one that I have here with all the fancy scrolls and designs. Now, if we're dealing with a hot water system, and as you can hear that the valve is starting to quiet down, which is exactly what it's supposed to do. If you're dealing with a hot water system, you know, a lot of people make a lot of mistakes in adding on more work for themselves. Me, hold on one sec. Sorry about that. Me, the type of person that I am, I know when it comes down to my home, or especially when it comes down to a heating system, I like to minimize the work as much as possible. I mentioned how this radiator was a hot water radiator, which still can be converted to a hot water. It can run on any system that I say that I want it to run on. I can hook it up to any system. Now, let's say you have a hot water system. As a matter of fact, give me a second. I gotta get something to demonstrate. Oh, better yet, to hell with it. We're gonna just go with it anyway. Okay, this is what you call a hot water air vent. Okay, it has a little slot for a flathead screw to turn it on and off to basically bleed it. And this is something that you would manually bleed. Now I'm using my thumb, and it really shouldn't even do that, but this is something that you would manually use to bleed out the radiator whenever you first start it up in a heating system, or anytime you want to get air out of the radiator or you want to properly vent it, which is an effective way to do it, but it's still, you know, it's, just from what I've seen, it doesn't work very effectively. What I do recommend, however, is that you get one of these. Now this is a hot water air vent, but this is an automatic vent. Basically, the only thing that you have to do is just keep this little screw open partially, or you can take it off all the way. And what will happen is, as the water builds up inside of the radiator and reaches the air vent, the vent will lock out, and it will solely vent only to let out any excess air that might build back up inside of the system, leaving you a radiator that's completely filled with water. Now, some of the common mistakes that people make when it comes down to a hot water radiator and a steam radiator, you have to know exactly where to place your vents. Taking a look at this radiator here, the one directly in my living room, this has the air vent pretty high, as a matter of fact, for a steam radiator that runs off of a one-pipe system. If you was dealing with the common radiator, this air vent would be substantially lower. But they set this radiator up, or the air vent up like this, because the radiator is this is a steam radiator exclusively. So that's the reason why they put the air vent higher, because all the steam comes from the bottom and has to make its way up. Basically, it comes through all these sections and then makes its way to the back. Now, if this were a universal radiator that runs off of a hot water or steam system, that would be a very poor installation. Now, let me show you exactly what I mean. Taking a look at this here. Okay, you see that I got my universal radiator. I'm going to show you exactly some typical things that you would see when it comes down to operating one of these. Okay, if you take a good look over here, you see that I got a plug on the top of the radiator. Not the big one, but you see there's one right above it. Okay. Now, in a lot of cases, what you'll see is someone take an Allen key or a flathead screwdriver and take this plug out. And basically what they'll do, as you can see, I wrapped it with a bunch of Teflon tape, and that's something else that I recommend that people use when it comes down to dealing with plumbing, especially when it comes down to dealing with heating, is use Teflon tape. A lot of people think that it's old and a lame technology, but it works very effectively. But nevertheless, what they'll do is they'll take one of these and put this on the top of the radiator, which is simple, and it can get the job done. And basically, when you need to bleed the radiator out, you basically take a screwdriver. And in this case, I don't have a screwdriver. As a matter of fact, let me go ahead and get one. Oh, better yet, I got something a little better. I got a flathead bit. So they'll take the flathead screwdriver and they'll basically adjust the air vent for what they needed to do, basically bleeding out the radiator. Now in this case, what I would do is I wouldn't use any of these at all. These are very cheap and a cheap way to get your work done, but like I said, it means that you have to constantly be doing work every single winter. Basically what I would do is I would get a connection, let me zoom out, like this here. And I'm going to show you exactly how I'm going to install this. Now I use Teflon, which is something that I recommend that anybody do when it comes down to putting together a heating system for, or any type of plumbing work. Teflon, the reason why I use Teflon tape is because Teflon tape basically will keep the metal from freezing up between one another, especially if you're dealing with hot steam or hot water. The metals can freeze together in a rapid period of time, so it's best to use a little Teflon tape, which I'm doing right now. Wrap a little Teflon tape around here, and in some cases if you desire to use a little pipe dope, you can do that as well. Okay, put my nipple right in here, get my channel arch into a slight snug. Okay, and then what I'm going to do is place this elbow right above the nipple. Now, the difference between a steam heating system and a hot water system, a steam heating system operates at very low steam pressure, which is more than enough to heat an entire building in relatively big buildings. Hot water systems operate at higher pressure. Why? Because of the water weight. Now I'm going to install my air vent. Now, although I do not have the radiator hooked up to anything right now, so I couldn't actually test it and show you exactly how it will work on hot water, I can just give you a demonstration on what it is that you should do when it comes down to installing an air vent for a hot water radiator. Now this is the best type of connection that you can use when it comes down to a hot water system, and basically all you would have to do is keep that partially cracked open, and what it will do is basically vent out the radiator automatically. So whenever the heat comes on, even if you got a system that's not filled with water, whenever the boiler starts to make heat, that water is going to expand. It basically taking up whatever space or leftover spaces that are inside of the radiator. So you can still get heat even if your boiler is not filled up all the way, which these are very effective valves. I recommend that people use this when it comes down to a hot water system. Now, if you are dealing with a steam heating system, take a look. If you're dealing with a one-pipe steam heating system, and I'm going to show you the air vent slot in just a second. If you take a look at this type of radiator, the air vent, the hole for the air vent is substantially lower. As a matter of fact, let me point that out with the substantially lower. Why? Because the steam more than likely is going to come from the top of the radiator through this section here, from the cutoff valve through the top, and then work its way back down. So the lower you have that air vent, the better off, or the better possibilities your radiator has of being able to heat up. Even with this little guy here, you can see that the air vent hole is very low. Okay. The difference between steam systems and hot water systems, or the advantages better yet, I should say, steam gives you a better heating ratio. It gives you far more BTUs than hot water. In some cases, it can even give you a faster heat than hot water. Now, both systems are very good and very effective. I recommend that you use either steam or hot water. I don't know exactly which system is more efficient. They say that hot water systems are more efficient. I'm not sure of that. I have not been able to prove that. I'm still trying to run tests to find out whether that's completely true. But with a steam system, you will get far more BTUs out of the radiator, because remember, in order to build up steam, you have to at least bring up 215 degrees before water even starts at a boil. And that's just to get it at boiling point. Now when you're bringing it up at pressures, you are now bringing that water to 225 degrees, 230, 240, even in some cases 250 degrees, depending on how much pressure you're operating at. Remember, the more pressure that you have, that's the hotter the BTUs of heat you're going to get. Now when it comes down to a steam system, you do not need to use a lot of pressure. If you are operating in a small house, you need no more than about 2.5 psi. If you're burning any higher than that, you are wasting fuel, because it does not take that much steam pressure to heat up a big building. You can heat up a big building off of just 2.5–3 pounds of steam pressure. As a matter of fact, I run a residential building where I heat the building up solely off of about 2.5–3 pounds of steam pressure. The maximum that I ever go to when I heat up that building is only 5 pounds of steam pressure, and my boiler shuts off. But the benefit with a steam system is that you get more BTUs out of the radiator. If you have a cast iron radiator, it will hold the heat for hours, even with steam, after the heat has shut down. Now, if you have a hot water system, the benefit with that is that it doesn't hold the same BTUs, but it will hold the heat much longer. So your radiator might stay hot for 3 or 4 hours if you have it on a hot water system, versus with a steam system, you might have it hot for about an hour, maybe an hour and a half, maybe 2 hours before you start losing the heat. The disadvantage when it comes down to hot water is that hot water doesn't carry its heat as well as steam. Meaning with steam, as long as you have it under pressure, you can pretty much keep it close to the same pressure, even at the furthest distance on the heating system. A hot water system, you're going to have certain parts that are very warm or very hot on certain parts of the radiators, or certain radiators that don't get as hot. Those are the disadvantages when it comes down to hot water systems and steam systems. Steam systems, the disadvantages with that is if you don't set it up the right way, you will get substantial amounts of banging, which can be very irritable, which can be in some cases even shocking or startling if you're not careful. But if you know what you're doing, and as you take a look, my radiator is still on, and as a matter of fact, you can't even hear it, because I told you I set up my system to the point where I don't have problems with banging. I don't have problems with leaking air valves. I don't have problems with cutoff valves. No leaks out of my joints. And everything's basically running the way it's supposed to.